So let's say that I am a drug company and I've come up with a medicine that I think will help folks with diabetes. And in particular, I think it will help reduce their hemoglobin A1C levels. And for those of you who aren't familiar with what hemoglobin A1C is, I encourage you, we have a video on that on Khan Academy. But the general idea is if you have high blood sugar over roughly a 3-month period of time, high blood sugar, and I could say high average blood sugar, you're going to have a high A1C, a high hemoglobin A1C level. And if you have a low average blood sugar over roughly a 3-month time, you're going to have a lower hemoglobin A1C. So if taking the pill seems to lower folks' A1C levels more than is likely to happen due to randomly or due to other variables, well, then that means that your new pill might be effective at controlling folks' diabetes. So in this situation, what we're trying to, when we're constructing an experiment to test this, we would say that whether or not you are taking the pill, this is the explanatory variable, and the thing that it is affecting, the thing that you're hoping has some response, in this case you want to, the A1C levels are your indicator of whether it has helped controlling the blood sugar, we call that the response variable. That right over there is the response variable. So how are we actually going to conduct this experiment? Well, let's say that we have a group of folks. Let's say that we have been given a group of 100 folks who need to control their diabetes. So 100 people here who need to control their diabetes. And we say, all right, well, let's take half of this group and put them into, I guess you could say, a treatment group, and another half and put them into a control group, and see if the treatment group, the one that actually gets my pill, is going to improve their A1C levels in a way that seems like it would not be just random chance. So let's do that. So we're going to have a control group. So this is my control group, control, and this is the treatment group. This is the treatment group. And you might say, okay, we'll just give these folks, the treatment group, the pill, and then we won't give the pill that I created to the control group. But that might introduce a psychological aspect that, you know, maybe the benefit of the pill is just people feeling, hey, I'm taking something that'll control my diabetes. Maybe that psychologically affects their blood sugar in some way, and this is actually possible. Maybe it makes them act healthier in certain ways. Maybe that makes them act unhealthier in certain ways because they're like, oh, I have a pill to control my diabetes, my blood sugar. I can go eat more sweets now, and it'll control it. And so to avoid that, in order for just the very fact that someone says, hey, I think I'm taking a medicine, I might behave in a different way, or it might even psychologically affect my body in a certain way, what we want to do is give both groups a pill. And we want to do it in a way that neither group knows which pill they're getting. So what we would do here is we would give this group a placebo, and this group would actually get the medicine. But those pills should look the same, and people should not know which group they are in. And that is when we do that, that is a blind experiment. Now, you might have heard about double-blind experiments. Well, that would be the case where not only do people not know which group they're in, but even their physician or the person who's administering the experiment, they don't know which one they're giving. They don't know if they're giving the placebo or the actual medicine to the group. So let's say we want to do that. So we could do double-blind experiment. So even the person giving the pill doesn't know which pill they're giving. And you might say, well, why is that important? Well, if the physician knows, it might, or the person administering or interfacing with the patient, They might give a tell somehow. They might not put as much emphasis on the importance of taking the pill if it's a placebo. They might, by accident, give away some type of information. So to avoid that type of thing happening, you could do a double blind. And there's even, some people talk about a triple blind experiment, where even the people analyzing the data don't know which group was the control group and which group was the treatment group. And once again, that's another way to avoid bias. So now that we've kind of figured out, we have a control group, we have a treatment group, we're using A1C as our response variable, so we would want to measure folks' A1C levels, their hemoglobin A1C levels, before they get either the placebo or the medicine. And then maybe after 3 months, we would measure their A1C after. But the next question is, how do you divvy these 100 people up into these two groups? And you might say, well, I would want to do it randomly. And you would be right, because if you didn't do it randomly, if you put all the men here and all the women here, well, that might, first of all, sex might explain it, or the behavior of men versus women might explain the differences, or the non-differences you see in A1C level. If you get a lot of people of one age or one part of the country or one type of dietary habits, you don't want that. So in order to avoid having an imbalance of some of those lurking variables, you would want to randomly sample. And we've done multiple videos already on ways to randomly sample. So you're going to randomly sample and put people into either groups. In a very simple way of doing that, you could give everyone here a number from 1 to 100, use a random number generator to do that. And then, or you could use a random number generator to pick 50 names to put in the control group, or 50 names to put in the treatment group, and then everyone else gets put in the other group. Now, to avoid a situation, just randomly, by doing a random sample, you might have a situation where there's some probability that you disproportionately have more men in one group or more women in another group. And to avoid that, you could do really a version of stratified sampling that we've talked about in other videos, which is you could do what's called a block design for your random assignment, where you actually split everyone into men and women. And it might be 50-50, or it might even be, just randomly here. You got, 60 women and 40 men. And what you do here is you say, okay, let's randomly take 30 of these women and put them in the control group, and 30 of the women and put them in the treatment group. And let's put randomly 20 of the men in the control group and 20 of the men in the treatment group. And that way, someone's sex is less likely to introduce bias into what actually happens here. So once again, doing this is called a block design, really a version of stratified sampling. Block design. And there might be other lurking variables that you want to make sure it doesn't just show up here randomly. And so you might want to, there's other ways of randomly assigning. Now, once you do this, you see what was the change in A1C. If you see that, hey, the change in A1C, well, one, if you see there's no difference in A1C levels between these two groups, and you're like, hey, there's a good probability that my pill does nothing. And once again, it's all about probabilities. There's some chance that you were just unlucky, and it might be a very small chance, and that's why you want to do this with a good number of people. And as we forward our statistics understandings, we will better understand at what threshold levels do we think the probability is high or low enough for us to really feel good about our findings. But let's say that you do see an improvement. You need to think about, is that improvement, could that have happened due to random chance, or is it very unlikely that that happened due purely to random chance? And if it was very unlikely that it happened due purely to random chance, then you would feel pretty good, and other people, when you publish the results, would feel pretty good about your medicine. Now, even then, science is not done. No one will say that they're 100% sure that your medicine is good. There still might have been some lurking variables that that our experiment did not properly adjust for. That just when we even did this block design, we might have disproportionately gotten randomly older people in one of the groups or the other, or people from one part of the country in one group or another. So there's always things to think about. And the most important thing to think about, even if you did this as good as you could, you still, some random chance might have given you a false positive or you got good results even though it was random, or a false negative. You got bad results even though it was actually random. And so a very important idea in experiments, and this is in science in general, is that this experiment, you should document it well, and the process of replication. Other people should be able to replicate this experiment and hopefully get consistent results. So it's not just about the results, it's your experiment design. Other people should it should be an experiment that other people could and should replicate to reinforce the idea that your results are actually true and not just random or just due to some bad administration of the actual experiment.